It is Tuesday morning. Somebody on your team bumped a library to the next version, a tiny bump, 2.0 to 2.1, and now one of your tests fails. Not a test somebody just wrote, a test that has sat there, green, for 8 months. You open the file it belongs to. Nobody has touched it. You check the history. No changes. You read the library's release notes, and they say, removed some duplication. One line. Here is the strange part. Every one of these files, read on its own, is correct. The library is correct. Your class is correct. The test is correct. And together, they are wrong.
So this video is about one thing: how two classes get wired to each other. That is the whole subject. When you write a class, you almost never write it alone. It leans on another one. And there are exactly 2 ways to arrange that. You can build your class out of the other one, using the keyword extends or the parent's name in brackets. Or you can hand your class the other one as an ordinary value it keeps in a field. That is it. That is the whole choice. We are going to look at what the first option actually buys you, what it quietly costs you, and how the second one works instead. This is not about the solid letters. It is not about memorizing design patterns. It is not about one language's syntax. It is about which of these wirings still lets you change your mind later, once somebody else's code starts moving underneath you.
Before any code, let me kill the most common confusion. Most people are taught that inheritance is a way to reuse code, and they stop there. So think about a kitchen mixer. A good mixer has a socket on the front. You clip in a whisk for cream. You unclip it and clip in a dough hook for bread, a flat paddle for cake mix. The motor spins. It has no idea what it is turning. You choose the attachment at the moment you cook, and you can change it halfway through. That is composition. Now imagine a different product. Same manufacturer, same motor, same housing, but the whisk is built into the body. It is one object. There is nothing to unclip. It works beautifully. It also means that when the manufacturer redesigns the gearbox next year, your whisk turns differently, and you do not get a vote. That is inheritance. Both of them make a cake. Only one of them lets a stranger rebuild your machine while you are asleep.
So let us be precise about what that keyword does. When you write a class that inherits from another one, you are not taking a photocopy. That is the mental picture almost everybody starts with, and it is the wrong one. A copy would be safe. A copy would freeze the parent's code at the moment you wrote yours. What you actually get is a live wire. Your class is attached to whatever that parent code becomes, release after release, forever. And it goes further than that. When you replace one of the parent's methods with your own, your method does not just sit next to the parent's code, it sits inside it. Anywhere the parent calls that method on itself, it is now calling yours. Neither file says so. Let me show you what that does.
Here is the library. It is deliberately boring. A basket holding a list of items. 2 ways to put something in. Add for one item, and add all for a whole list at once. Now look at the last line, because everything that follows hangs on it. Add all loops over the items and appends each one straight to the list. It does its own work. It does not call add. Nobody documented that. Why would they? It is an internal detail. It is 3 characters. If you ask the person who wrote it whether add all goes through add, they would probably have to open the file and check. And here is your class. It is a completely reasonable thing to write. You wanted a basket that keeps count of how many things went into it, so you inherit from basket, with its name in the brackets, and you get both methods for free. Then you override each one. Add adds 1 to the tally, then calls super.add, which means now do the normal thing the parent would have done. Add all adds the length of the list, then calls super.addAll. 3 items go in, and the tally says 3. You write that as a test. It passes. Code review approves it. It ships. And for 8 months, it is completely correct. Now the release. Somebody who maintains that library is tidying up. They notice add all is repeating what add already does, and they replace one line. Instead of appending to the list, add all now calls self.add. It is a genuine improvement. It is one line. It is a patch release. Watch what happens to your class. You call add all with 3 items. Your version runs first. The tally goes up by 3. Then it calls super.addAll, which is the library's new version. That loops and calls self.add.
But self is your object, so self.add is your override. It runs 3 times, and each time it adds 1 to the tally. 3 plus 3. The tally says 6.
3 things went into the basket. The counter says 6, and 1 line changed in a file no one on your team owns. Now think about where you would even look for that. Your class is untouched. Its tests were green the day you wrote them. The library's own tests are green too, because the library counts nothing. The bug does not live in either file. It lives in the space between them, and there is no test suite in the world that watches that space.
This has a name. It is called the fragile base class problem, and it is one of the oldest known traps in object-oriented programming. Here is the mismatch that causes it. What you thought you were inheriting, some code that appends to a list, 2 methods you would rather not retype, a shared name for the same idea. That part is real. That is why inheritance feels like reuse. But what you actually inherited is much bigger. You inherited every method the parent calls on itself. You inherited the order it calls them in. You inherited the fact that today, add all happens to go through add. And you inherited every future version of all of that. None of it is written in your file. All of it can change without you. The parent is having a private conversation with itself, and your override has quietly joined in. So here is the same class wired the other way. Look at the first line. There are no brackets, there is no parent. Instead, the constructor takes a basket as an argument and keeps it in a field called inner. Then add does its own bookkeeping and calls inner.add. Add all does its bookkeeping and calls inner.addAll. Same 2 methods, same tally. And at the bottom, you build it by passing a real basket in. The test still says 3. Now here is the part worth sitting with. That test says 3 on version 2.0. It also says 3 on version 2.1. The line that broke everything a minute ago cannot touch this.
Why not? Because of one word. Inside the library's add all, self means the library's own basket object, not yours. It has never heard of yours. So when it calls self.add, it calls its own add, does its own appending, and the tally is not involved. Everything you cared about is still there. The same 2 public methods, the same running count, the same 1-line test. What is gone is the parent's ability to reach back into you. It cannot call your override. It cannot depend on your fields. It cannot change your behavior in a patch release. It only ever sees a call arriving from outside, through the front door, like any other caller. That is not discipline, and it is not code review. It is structural. There is simply no path.
And you get something back for the trouble. The thing your class works with is now an argument, which means it is a value, which means it is yours to choose. In production, you pass the real basket. In a test, you pass a fake one that records what it was asked to do, and your test runs in a millisecond with no library involved at all. You can wrap 2 different objects, or the same one twice. You can point it at anything that has an add and an add all, and it does not have to be a basket at all. And if you decide the counting was a bad idea, you delete 1 word at the call site and pass the plain object. With inheritance, none of that is available, because the relationship was decided at the moment the class was written, and it is welded shut.
Now the honest part, because composition is not free. Look at the bottom of this file. Every method you still want, you have to write out again by hand. Clear, length, iterate, peak. Inheritance gave you all of those for nothing. You also lose the free is a basket check, so any code that asks whether your object is a basket will now say no. And there is a third cost, at the top of the file. That protocol block is you writing down, explicitly, which methods you actually need from the thing you are holding. That is real design work. Inheritance let you skip it by taking everything. Taking everything is exactly how you ended up with 6.
So when is extends the right answer? It has a genuine job. It is just narrower than most people are taught. Inheritance is honest when your class truly is a kind of the parent, everywhere, forever, and not just today. When you own both files and ship them together, so nobody can change one behind your back. When the parent was designed to be inherited from, and its documentation actually tells you which of its methods call which. And when anywhere the parent works, yours works too, with no surprises. Reach for composition when you only want it 2 or 3 of its methods, when the parent belongs to somebody else on their release schedule, when you want to swap it or fake it or wrap 2 of them, and especially when you are reaching for extends mainly to avoid retyping. The test is one sentence, said out loud. Is a counting basket a basket? Or does it just have one?
Which gives you the line worth remembering. Inherit to be, compose to have. Inheritance is a promise about identity, not a shortcut for reuse. When you make it, you hand somebody else a key to the inside of your class, and they can walk in anytime they release a version. Composition charges you for that safety, in forwarding code and in one design decision you have to make consciously. What it buys back is the only thing that really matters in code you have to live with. You can change your mind later. And you were never actually choosing between reuse and no reuse. You were choosing who is allowed to change your object. With inheritance, that is the parent's author. With composition, it is you.
If that made the word extends look different than it did 10 minutes ago, that is the whole idea. One concept all the way down to the code, every time. Hit like and subscribe.